I'm gonna start some tutorials about this 2 for NoLimits Roller 2, which is called FVD++. As the name suggests, it's a force vector design based program which allows you to actually shape your track in terms of the g-forces directly. So here's the program. Here's the space in which your coaster is gonna be. And for you to navigate throughout the space, you can just right click on the mouse and define a direction in which you're gonna move. For you to move forwards, you can just press you can just press W. For you to go backwards, you can press S. For you to go faster, you can press Shift plus the button for you to move like faster forwards, faster backwards, or you can move to the left by pressing A or to the right by pressing D. You can use the scroll button of the mouse for you to move either upwards or downwards. Okay, this is the file section of the program where you can start a new project or load one that exists already, or save as an FVD file, or export as an NL2 element for the actual simulator. So let's get started and do some basic elements here in FVD. So the intention of this tutorial is to talk about the station and the lift hill. So, and also of course some other basic parameters are you gonna have to define for you to work in the FVD. Once you click on a name the track, those 4 options here are gonna show up and you will be able to adjust them. First thing ever you have to do is go to properties. Well, here in properties you have to adjust 2 main things. First is the friction parameter, because although the physics, theoretically, although they are both 0.030 in FVD and NL2, the physics on both, they kind of works like the physics in both programs work differently. So you will have to adjust the friction parameter. It seems like the friction in NoLimits 2 is lower than the one in FVD, so you will have to adjust for a lower value. By my experience, I can say you can adjust that for 0.024. That should be okay. And the other important value you have to adjust is the hurtline height. What is the hurtline height? So for those who don't know what it is, in the roller coaster projects, the engineers have to set a point of reference where they can calculate the g-forces upon the rider's body. So that that that's that hurtline height means the height from the base of the track to the actual virtual line that goes through the heart of the rider. So this is the point of reference in which the engineers use to calculate the g-forces. Let's start with the standard, which is 1.10. A lot of different models of roller coasters use this as a reference. For example, the classic steel looping. Oh, by the way, in the help section, you can check the different hurtline values for different kind of roller coasters, different styles. Models. So there's the hypercoaster 4-seat, which is also 1.1. There's the LEM launched coaster, the Zumperla Twister. A lot of them use 1.1, but regardless of which one you're gonna use, you just have to adjust it properly. Let's say we want to start with a classic steel looping coaster, so you just go ahead and close it, and here it's 1.1 already, and the friction parameter. It's really important that you adjust the friction parameter at the very beginning, because otherwise if you adjust it later after some part of your project being done, you're just gonna ruin your project, because the FVD we assume that there's a different value for the friction, so the entire track will change completely. So I recommend you do this at the very beginning. Now we can actually start our project. So the first thing the first thing that people usually do is the station. So the station is basically a straight section of the track. So you can just go ahead and edit. This is the anchor. Anchor is like an invisible point on the space, in the space where the roller coaster starts. So for you to be able to start this station, you just have to go ahead and add a straight section. So our straight section is over here. Yeah, there we go. This yellow line here represents the hood line height. You can actually adjust the beginning of your coaster in terms of coordinates. So for example, you can click on anchor, and here are those initial parameters that you can change if you want. So this is the x axis, the y, and the z axis. So by changing this one, you can move your coaster like this on the x axis. By changing this one, you can move your coaster up or down. Let's just set it for 8. I think you should be fine. And this one is the z axis, so you can move sideways. Those are other angles that you can change, other parameters that you can change in terms of angle. So for sigma, I guess this one would change the angle of your track like this. Basically it turns your track around the x-axis, but that is not realistic, so let's just set it for 0 as it was before. This theta angle is gonna change basically the pitch of the initial section. Usually there are some models of roller coasters sorry, that have a little inclination like this, but it's not our case for this one, so let's just keep it 0. For this last one, you can actually change the angle of your first section in terms of axis y. It turns around the axis y. That's a basic roller coaster, so I recommend you not changing any of those unless you are doing something specifically, something particular about your project. Otherwise, just let them 0. So let's go back to our straight section. This is going to be the straight section, which represents in this tool the station on the simulator. Let's set the length here for 20 meters. If you don't feel comfortable working with this unit, meters and meters per second, you can just go ahead and go to help. You can either go to help conversions and convert those units here, or you can also go to edit options and change the measurement here. You can put either English, which is feet and miles per hour, or metric and kilometers per hour. I mean, metric meters per second, or metric, which is meters and kilometers per hour. I usually do meters per second. I think it just works well, so that's it. Those are some changes that you can make in terms of background color, shadow quality, mesh quality, FOV. I just usually let them standard, so those are the colors that represents the parameters that we are going to be talking about later. So I just let them like this because it's just in terms of representation, so just let them like this. So we so far have done something about straight sections, which is not that much. Let's go ahead and do something else. I mean, something a bit more complex. The second option of section you can have here is the curved section. If you want to start like the station, then a curved section, you can just add the curved section. There are other parameters that you can set for the curved section, of course differently from the straight section. That can be the track radius. You can adjust the track radius the way you want, the way you think it fits better. I usually put just something about 10. And you can add the total angle of the curve, like the total angle that the curve is going to complete. For example, a half circle should be 90 degrees. No, a quarter of circle, sorry. And a half circle should be 80 degrees like this. Let's just let it 90 degrees. The direction of the curve is a parameter that defines whether the curve is gonna go to, for example, if you look straight in the front of the track, in the front of the straight section of your track, you can see that the direction changes like this. It's like establishing a circle around this axis, the x-axis, and then the direction of the curve changes like this. So that can go from minus 180 degrees to positive 180 degrees, like this. So for example, if you want to start your roller coaster going in a curved section but at the same time going downwards, you can set something like this. It should be fine like this. But let's start simple and just establish it for 90 degrees. That's fine. This last parameter here, which is there are actually two in one, which is lead in and lead out. I'm not quite sure about what this represents in practical terms, but I just know that if you increase the lead in, a more straight section is gonna be added to the beginning of this track, of this part here. And if you increase the lead out, a more straight section is gonna be added for the end of the segment. I don't think that's quite useful, but let's just set it for 10. You can actually set it for 0 as well. In this example here at the beginning of the coaster with 90 degrees direction of curve, regardless of you put 0 or 10 or whatever, it should be just fine. But be aware that increase the straight section right before the beginning of the curve for leading and right after the end of the curve for lead out. I'm not quite sure why they use degrees to measure this. Anyways, after this curve, you can do your left hill. So for you to be able to start your left hill, you're gonna have to add a new curved section, and then for this one you're gonna have to change the direction of this section. The direction that goes upward is 0. Of course, we don't have something like 90 degrees, so you can actually reduce the total angle of your curve and establish it for about 30. That should be fine. And once again, people usually set it for 0 or 10, but I particularly prefer it in 10. I don't really think it changes anything for this part. That can influence something later on in this tutorial, or maybe in some other tutorial that I'm gonna explain about. Sorry. So after this curved section that goes upwards, you can just go ahead and add a new straight section, and let's set the length of the straight section for about 40. And then for you to complete your left hill, you're just gonna have to add a new curved section. The curved section that goes downwards is represented by the direction of 130, like this. You can adjust the total angle and the direction of your left hill according to your needs. So let's just put, I'm sorry, that should be 180, yeah. So let's just put something about 40 here, and the track radius about 12 for a basic example. That should be fine. So we have done our station and our lift hill so far, but there is something really important that you guys have to be aware of, which is the speed of the segments. In FVD++, you cannot actually define whether a segment is a station or a lift hill, but actually you can adjust the speed of each segment, which means that gonna be the station on the simulator, and that gonna be the lift hill. Usually the station has the same speed of the lift hill, so you can go back to straight section and set your speed here in this part, fixed speed, for about 2 meters per second. If all of your segments from the station to the lift hill are fixed speed segments, you can just go ahead and set the speed for the last fixed speed segment of the track, which is this curved section right here. You don't have to go to each one and adjust the speed, because it doesn't affect anything that is after them, if that makes sense. Like, you have this curve, you have this other curve, the actual lift hill, and the last segment. If you just adjust the last segment speed, it doesn't really matter, because the simulator will assume that this whole section has the same speed. And what really matters in this case is the final speed here so that the train will be able to perform the drop according to the final speed at the top of the lift hill. So you guys might have noticed that this part over here shows a graph. This graph actually represents three, I guess, main things, which actually two main things: the banking and the force. The banking is here and the force is there. It's not showing anything right now because we haven't started the force sections yet, like this one. Neither the geometric section. Those are a little more complex type of sections. But basically, this part here shows the banking. You can adjust the banking of your either the straight section or the curved sections that you added. Let's say I want to adjust the roll of this section right here, which is in red. By the way, that's how the FVD represents the section in which you were working on. So let's say I want to adjust the roll of the section right here. You can just go ahead and click. You can see, like, if I select this one, this respective section is gonna be in white. So you can just go ahead and click upon the line, and then this part here is gonna show up. Well, you can see that this parameter here is set to be 0. So if you want to adjust the roll of this part, you can either increase or decrease your roll. That's not what I usually do. I usually adjust the roll of the segment before I complete the other parts right after it. This is just in terms of example. You can see that the graph of the banking is kind of like a sine graph, like sine and cosine, those trigonometric functions. Why that happens? So FVD, one of the main things that FVD does, which I think is really cool, is you're not actually adjusting the banking or the roll. You're actually adjusting just the speed in which the roll varies. So what does that mean exactly? That means that in a particular period of time, your roll is gonna change in a set speed, which can be, for example, 25 degrees per second. But this graph shows up like this because at the beginning of the segment, from the beginning to the end, it's gonna increase and then decrease again. Because if the graph has a different behavior, for example, it goes from here to there and it doesn't change, it doesn't go back to 0 again. It means that the next segment is gonna follow the same value of roll speed sorry. So that means that the whole, like, all elements that you're gonna add after are gonna change the roll in the same speed of the first segment in which you adjusted the roll speed, I guess. So it's good for you to adjust the roll speed for a type of graph like this. But how can you do that? Those are the parameters that you can use to adjust the type of graph that the roll or whatever you were adjusting is going to perform. So if you put linear, you can see that that's the behavior of the graph. So at the end of the segment, the speed will gonna continue like this, and you can see what happens to the left hill and the other curved section. But if you let it for quadratic, it's pretty much the same thing in terms of it continues to vary the roll along the other segments. But if you put quartic, you see that this the roll speed goes back to 0, which means that the other elements, they do not continue to change the roll. You can see that they show that they behave differently from the other examples that I gave. And there's always, there's also the other types such as cubic or quintic, sinusoidal, plateau. I recommend you use the quartic type of graph for the roll speed. That doesn't look pretty, so let's just put 0. As I said, that's just in terms of example. So we have done our lift hill and our station, the basic, like the basic things of a roller coaster. Oh, that's another thing. For the roll, you can actually set two options for the type of roll. You can set Euler or Quaternion. There is a mathematical difference in both, but I'm not quite sure how they work in terms of mathematics. Like Quaternion and Euler are functions, I guess, roll functions. People usually like to use Quaternion, and indeed they behave better. I think if you use Quaternion, you have a better control of the roll, mainly if you are using a fourth section. But Euler is a bit complicated to use and for you to control. For example, if you are dealing with an inversion on the FVD, it's hard to control the inversion with the Euler orientation. So you better let the orientation for Quaternion for most of the parts of the roller coaster. There are one or two elements that in which you should be using Euler, but maybe I can talk about them later on, not for this tutorial because this one's pretty basic. So I think that's it for now. You guys are already aware of a lot of things you can do to work with FVD. You are aware of how you can start your station in your lift hill. On the next tutorials, I'll be talking about the drops and the force sections, the geometric sections, and a bit more complex stuff. So I hope you guys enjoy it, and thank you for watching this. See you guys later.